Hello mga ka-wisdom! Welcome to Wisdom is Power channel. Kung bago ka pa lang sa channel na ito, huwag kalimutang mag-subscribe, i-like, mag-comment at i-share ang video ito. Click mo na rin ang notification bell to receive more wisdom videos na katulad nito. Salamat! Now we're going to talk about the generated voltage of an alternator. To understand this, we need to study the equivalent circuit of alternator or the synchronous generator. So makikita natin dito sa ating circuit, we have a simple series circuit composed of reactance of armature reaction, the armature leakage reactance, and the armature resistance are connected in series. The sum of reactance of armature reaction and the armature leakage reactance is called the synchronous reactance or simply X sub S. The E sub G is the generated voltage and V sub L is the load voltage. IA or I sub A is the armature current. R sub A is the armature resistance. So, to simplify the circuit, we just add the reactance of armature reaction and the leakage reactance. So, we call it synchronous reactance. So, masisimplify na lang yung circuit natin sa very composed of armature reactance or armature resistance in series with the synchronous reactance. So, applying Kirchhoff's voltage law in the circuit, then the generated voltage is equals to voltage drop across the synchronous reactance and the armature resistance plus the load voltage. So we all know that to get the voltage drop, it's simply the armature current multiplied by the resistance plus the synchronous reactance plus the load voltage. And we all know that R plus J X sub S is simply the impedance. So the generated voltage will be equals to the armature current multiplied by the synchronous impedance plus the load voltage. So remember that this equation is in complex form, whether you express it in polar form or rectangular form. So here is the equivalent phasor diagram. So using the Pythagorean theorem, we are looking dito sa malaking triangle ODF. So, pag gagamitan natin siya ng Pythagorean theorem, that is the hypotenuse, the square of the hypotenuse is equals to the sum of squares of the opposite side and the adjacent side. O that is OD to be squared is equals to OF, the adjacent side, to be squared plus FD, the opposite side, to be squared. So, you will notice also that OF is simply line OG plus line GF. So, that is to be squared also. Plus, the opposite side, which is FD squared, is simply FC, line FC, plus line CD to be squared. So, simplifying the equation, the generated voltage to be squared is equals to VL cosine theta plus I sub A multiplied by RA to be squared plus VL sine theta plus I sub A multiplied by X sub S to be squared. So getting the value of the generated voltage, our equation will be the square root of VL cosine theta plus IA RA to be squared plus quantity VL sine theta plus I sub A X sub S to be squared. So this will be our equation for the generated voltage, the second equation for our generated voltage. So remember that this V sub L or the load voltage is per phase. So we have to do some adjustment from the given. Well, the Greek letter sigma is the angle between the generated voltage and the load voltage. Where theta, as you can see in our phasor diagram, is the angle between the load voltage and the armature current. So the power angle or the sigma is also called torque angle, rotor angle, and load angle. So to summarize, the generated voltage equation for an alternator is simply like this. The square root of VL cosine theta plus IA RA to be squared plus the square of VL sine theta plus IA x sub S. That is for lagging power factor. For leading power factor, we simply change the plus sign with minus sign. And for the unity power factor, so we will get the lagging power factor. Then we all know that the voltage and current are in phase when the power factor is 1. So simply means that the theta is 0 degrees. So cosine 0 degrees is equals to 1 and sine 0 degrees is 0. So therefore, the cosine theta will become 1 and sine theta is 0. Therefore, simplifying the equation for unity power factor, the generated voltage is equals to the square root of B sub L plus IA multiplied by RA plus the square of I sub A multiplied by X sub S. So these are the equation for different value of power factor. This is the generated voltage equation. So let's have practice problem number 1. A 50 MVA 30 kilovolts 3-phase synchronous generator has a synchronous reactance of 9 ohms and a negligible resistance. The generator is delivering rated power at a 0.8 power factor lagging at the rated terminal voltage to an infinite bus. Determine the excitation voltage per phase and the power angle sigma. So let us first write all the given. The apparent power is 50 MVA. The load voltage is 30 kilovolts. The power factor is 0.8. The synchronous reactance is 9 ohms. So we are asked to solve for the generated voltage. So for our solution, we use our first equation. The generated voltage is equals to the armature current multiplied by the impedance or R plus J X sub S plus the load voltage. So remember, we express this equation in complex form. So to get the angle, that is R cosine 0.8, and we will get 36.87 degrees. To get the voltage per phase, we simply B sub L, use the formula B sub L over square root of 3. This B sub L is the load voltage divided by square root of 3. So simply 30 times 10 to the raised to the 3 over square root of 3, and we will get 17.32 kilovolts. So another equation to solve for the armature current, that is the apparent power all over 3 multiplied by the phase voltage. So that is 50 times 10 to the 6 all over 3 multiplied by 17.32 times 10 raised to 3, and that will give us 962.28 amperes. Now, we already get the value of the armature current. We will attach the degrees. That is negative 36.87 because the power factor is lagging. So substitute all the values given for the generated voltage. So since R is, we have negligible resistance, so our equation will become 962.28 angle negative 36.87 multiplied by J9, the complex form, plus 17.32 times 10 to the raised to third power angle 0 degrees. And we will get 23.57 angle 17.1 degrees kilovolts. So the generated voltage is simply the 23.56 kilovolts, and the power angle is equals to 17.1 degrees. So this is our answer. So another approach or another solution for this problem, we can use our second equation to determine the generated voltage. Simply plug in all the values we get and all the values given, remembering that the armature resistance is negligible. So substituting all the values from our equation, then we will get 23.56 kilovolts for the generated voltage. So for the power angle, using the phasor diagram of the triangle or ODF, beta, let us assign the angle beta, which is the angle between the generated voltage and the armature current. Okay, so we will use the Greek letter beta to represent the angle between the generated voltage and the armature current. So using Ohm's law, using the trigonometric function of tangent, that is opposite over adjacent. Okay, opposite over adjacent. So that is beta is equals to arc tangent BP sine theta plus or minus I sub A x sub S all over BP cosine theta plus IA RA. So you will notice meron tayong positive negative na ginamit. So kung positive, that is lagging, at kung leading power factor naman, negative ang ating gagamitin. So since meron tayong power factor na lagging, so ang sign natin gagamitin is plus. So that is arc tangent 17.32 times 10 to the 3 multiplied by 0.6 plus 962.28 multiplied by 9 all over 17.32 times 10 to the 3 power multiplied by 0.8 plus 0. So the beta is equals to 53.97. So to get the torque angle or the power angle, we simply subtract the theta from the beta. So that is 53.97 degrees minus 36.87. That is equals to 17.1. This is the same from our previous solution. So for practice problem number 2, a Y-connected 3-phase 60 Hz alternator supplies a load of 10 megawatts at 0.85 power factor and at 11 kilovolts. The resistance and synchronous reactance are 0.1 ohms per phase and 0.66 ohms per phase, respectively. Determine the line-to-line voltage generated or the EMF generated. So first, we write all the given. Power is 10 megawatts. The load voltage is 11 kilovolts. The power factor is 0.85. The armature resistance is 0.1 per phase. And the synchronous reactance is 0.66 ohms per phase. So we are asked to solve for the generated voltage line to line. So for our solution, let's get the voltage per phase, which is equals to the load voltage divided by square root of 3. So that is 11 times 10 raised to 3 all over square root of 3. And we will get 6,350.85 volts. For the armature current, that is equals to power all over 3 multiplied by phase voltage multiplied by cosine theta. So substitute all the values, the armature current will be 617.49 ampere. So using the data, the armature current will be 617.49 angle negative 31.79 degrees because this is a power factor of 0.85 lagging. So using our first equation for the generated voltage expressed in complex form, then substitute all the values given from the problem and from our solution. Then the generated voltage is 6,625.47 volts. So to solve for the line-to-line generated voltage, we simply multiply this by square root of 3. So that is square root of 3 multiplied by 6,625.47, and that will give us 11.48 kilovolts line to line. And for our second solution, we simply use our second equation. And with our values given, we just plug in it to our equation, then this will become the general voltage is equals to 6,626.24 volts. And to solve for the generated voltage line to line, we simply multiply it by square root of 3. And this will give us the same answer of 11.48 kilovolts. For practice problem number 3, a 200 kVA, 400 volts, Y-connected, 3-phase, 6 Hz synchronous generator has effective resistance and synchronous reactance per phase of 0.1 ohms and 1.2 ohms respectively. Determine the generated EMF when the machine is delivering rated current at unity power factor. So this time, our power factor is 1. So writing all the given, the apparent power is 200 kilovolt ampere. The load voltage is equals to 400 volts. The power factor is 1. The armature resistance is 0.1 ohms. And the synchronous reactance is 1.2 ohms. So we are asked to solve for the generated voltage. So our solution, first, we have to get the voltage per phase, or the phase voltage, that is equals to load voltage divided by square root of 3. That is 400 over square root of 3. You will get 230.94 volts. And solving for the armature current, that is apparent power all over 3 multiplied by the phase voltage. So substitute the values 200 times 10 to the positive 3 all over 3 multiplied by 230.94, and we will get 288.68 ampere. So since the power factor is unity, so the angle for the current is 0 and also the voltage is 0 because they are in phase. So using our first equation for the generated voltage, we just simply substitute all the given values and the values derived. So the generated voltage is equals to 432.02 angle 53.13 degrees volts. So the power angle is simply 53.13 degrees. For the second solution, we just simply use our equation for the generated voltage for unity power factor. So simply the square root of Vp plus IARA to be squared plus the square of I sub A multiplied by X sub S. So using these values and substitute to our equation, this will give us 433.02 volts, the same with the previous equation or the the first solution. Then, for the power angle, that is, again, beta is used to represent, let us use the Greek letter beta, for the angle between the generated voltage and the armature current. So that is IA x sub S, the opposite over the adjacent, that is BP, which is the voltage per phase of the load voltage, plus IA RA. So substitute all the values, then the beta is equals to 53.13 degrees. So to get the power angle, simply subtract theta from beta. So that is, will give us 53.13 degrees minus 0 degrees. So our sigma, or the power angle, is 53.13 degrees, which is the same with our first solution. So that's all, mga ka-wisdom. So again, kung bago ka pa lang sa channel na ito, huwag kalimutang mag-subscribe, i-like, mag-comment, i-share ang video ito. I-click mo na rin ang notification bell to receive more wisdom videos like this. Thank you!